welcome you to the lecture. This is the first part for lecture 3, radical equations. My name is Jorge. So the objective for lecture 3 is that we're going to go ahead and learn how to solve radical equations. We're going to solve equations quadratic in form, and then we're going to solve equations by factoring. So I have just several examples I'm going to work through here. So the first example is that we have the cube root of 3x minus 1 minus 2 equals 0. So we're going to go ahead and solve this. So the first thing that we're going to do is we're going to move the 2 over to the right side. So we're going to add 2 to both sides. And then we're going to cube both sides, and that's going to get rid of the cube root sign on the left-hand side. And by doing that, we end up with 3x minus 1 equals 8. And then, of course, at this point in time, we're going to add 1 to both sides. And then we're going to divide both sides by 3, and we get x equals 3. So now we're going to go ahead and check it to ensure that this is in fact the solution to the original equation. And by substituting x with 3, we end up with 2 equals 2, and so that our solution set then is just 3. So the second example is we have the square root of x plus 1 is equal to negative x plus 1. So what we're going to do is we're going to square both sides. And by squaring both sides, we end up with x plus 1 is equal to x squared minus 2x plus 1. So negative x plus 1 squared is equivalent to x squared minus 2x plus 1. And then what we're going to do is combine like terms, so we end up with x squared minus 3x equals 0. We're going to go ahead and separate that, so then that becomes x times x minus 3. So then we set each factor equal to 0, and we end up with x equals 0 or x equals 3. We're going to make sure that they both work, so we're going to check them. So we substitute 0 for x, and we get 1 equals 1, so that works out. But then we substitute x with 3, and then we get 2 equals negative 2. So therefore, x equals 3 is not a solution to the original equation. So that's what we call an extraneous solution. Does not work in the original equation. So then the solution set is just 0. Now, the third example, we have the square root of 5x minus 1 minus square root of x equals 1. So what we're going to do is we're going to go ahead and move the square root of x over to the right side. So we're going to add that to both sides. So now we're going to square both sides of the equation. And what that's going to do is going to give us 5x minus 1 equals x plus 2 square roots of x plus 1. Then at this point in time, we're going to go ahead and combine like terms. So we have 4x minus 2 equals 2 square roots of x. So we want the square root of x by itself, so we're going to divide everything by 2. And that gives us 2x minus 1 equals square root of x. Now at this point in time, we want to get rid of the square root, so we're going to square both sides again. And then by expanding the left side, we get 4x squared minus 4x plus 1. And on the right side, we just get x. So we combine like terms, and now we have a quadratic equation that we've seen before. So we're going to go ahead and solve this. So we end up with 4x minus 1 times x minus 1 equals 0. Set each of those factors equal to 0. So we get x equals 1/4 or x equals 1. So now we're going to go ahead and check it to make sure it works. And by checking it, we find out that x equals 1/4 is not a solution, but x equals 1 is a solution. So therefore, the solution set for this particular equation is just 1. All right, so here we have an equation that looks quadratic in form. So we have x minus 2 squared minus 3 times x minus 2 plus 2 equals 0. So what we're going to do is we're going to go ahead and do some substitution. So we're going to substitute a variable for x minus 2. So we're going to let u equal x minus 2. Then u squared is equal to x minus 2 squared. So what happens is when we do this, now we can rewrite our equation in the form of u squared minus 3u plus 2. So remember the substitution, u is equal to x minus 2. So we're able to do this, and now we're able to just solve this equation. So let's factor it. So we get u minus 2 times u minus 1. Set each one equal to 0. So now u equals 2 or u equals 1. Now remember that at the beginning we let u equal x minus 2. So now we can go ahead and substitute again. So we end up with x minus 2 equals 2 or x minus 2 equals 1. So we solve each one. So we get x equals 4 or x equals 3. So here we have another example. So we have x minus 5 square root of x plus 6 equals 0. So we're going to let u equal the square root of x, then u squared equals x. So now we can rewrite the equation as u squared minus 5u plus 6 equals 0. Factor that. and then set each factor equal to 0, so we end up with u equals 3 or u equals 2. Now remember that u is the square root of x, so we can rewrite that. And then we solve for x, and so we get x equals 9 or x equals 0, so the solution set is 4, 9. So here's another example. So we have x to the third minus 2x equals x squared. So we're going to go ahead and solve this. So the first thing is we're going to subtract x squared from both sides. And then we're going to go ahead and factor out an x, so we get x times x squared minus x minus 2 in the parentheses. So now this expression in the parentheses is quadratic in form, so we can factor that. And by factoring, we get that becomes x minus 2 and then x plus 1. So we have 3 factors. We set each factor equal to 0, so we get 0, 2, negative 1. So the solution set is negative 1, 0, 2. So here's another example. Excuse me. So here we have x to the third minus 3x squared minus 4x plus 12. So the way that we're going to solve this is we're going to go ahead and group. So we're going to group the x to the third and the 3x squared, and we're going to group the 4x and the 12. And then we can go ahead and factor out a common term for each of the groups. So the first group, the common term is x squared, so we took out an x squared. The second group, the common term is a 4, so we took that out. So we end up with x squared times x minus 3. Minus 4 times x minus 3 equals 0. So now we put together the x squared and the 4, so we end up with x squared minus 4 times x minus 3. Now x squared minus 4, we can go ahead and factor that even further, so that's x plus 2, x minus 2. We set each factor equal to 0, and then our solution set becomes negative 2, 2, and 3. And that's the end of part 1, radical equations. Thank you.